Share my screen. Okay, good morning, everybody. Welcome to our CS40 class. First one of the week, maybe for many of you, first class of the week. We're pretty much halfway through our semester at this point. We have a handful of announcements here at the top of this file right now. Where I'm looking is in the topic 6 Python matplotlib folder inside of our CMC CSCI 040 GitHub repository. And if you scroll down, the very first one of these announcements at the top, so that you can sort of be working on it while I talk about the other things, is that there's a couple of files to make sure that you have downloaded today in order to be able to follow along with what we're doing in class. The first one is a little bit more involved. There's a bunch of zip files at this particular link right here at this GitHub repository. GitHub is very useful for sharing not just websites like we've used so far, but also for sharing data sets or code for analyzing data. And people do this all the time. And so this particular GitHub repository is a data set of all the tweets that President Trump has ever sent. And if you click on that, it will take you over to something that looks like this over here. There's a whole bunch of zip files over here with all of each zip file basically corresponding to the tweets for an individual year. And for the purposes of class, you just need to have access to one of these zip files. We'll be going over exactly what this JSON thing is over here and how these, like, what is the format that these tweets are stored in, how do you access them. But for your lab this week, one of the things that you'll be doing is you'll be doing an analysis of all the things that Trump has tweeted. And so in order to get access to all of this data, the easiest way to do it is this green button up here, this green one that says code, and this download zip right here. This will give you a zip file that contains all the contents of the repository here. In this case, it'll be a zip file of zip files. And you want to extract that somewhere that you'll be able to access it. This process for downloading these GitHub repositories, this green button here and this download zip, is something that you can do for any repository. It's not special to this one, but you could do it for anything that you stumble upon in the future that has data that you want to access. And so that's this first thing to download here. This next one, this notes_json.py file, that's what we will be going over a lot today. And so you'll want to have access to this file. And this file, again, is stored up here, notes_json.py right there. For going on, are there any questions about what to download or anything along those lines?
You're downloading it with like the green, like kind of like downloading all of them. Should that be downloaded like to, how would VS Code access that?
Yeah, so the question is, where exactly do you put it? How does VS Code access that? Because we've been having a number of different issues about finding files so far. And today, the very first thing that we're going to do in class today, when we get to the technical contents, is we'll be talking in very explicit detail this time about how Python works when accessing files. So you'll be able to access it no matter where you put it, but I just recommend wherever you normally download stuff, put it in there. For me, I created a folder called data that contains all of the final extracted things. And I thought that was a good way to organize things. Good question. The full answer will come here in like 5 or 10 minutes. Any other questions so far about the setup? Okay. Then more announcements. So this Friday, there's not going to be a dedicated lab session in class here. So the Friday class is canceled. And I also won't have office hours on Friday. The reason for that is I have to be traveling over fall break. I'm actually going to Korea. I'll be back on Tuesday sometime. Going there to talk about making machine translation better for Korean languages, and a whole bunch of other, I want to say weird languages because they're not your typical Google Translate languages, but they're not actually weird. So things like Quechua and other Native American languages, or ancient Greek, ancient Latin, a whole bunch of other extinct languages, and other things like that. If you are part of the data science major or end up for whatever reason going on to take the data mining class, which is like 3 classes away above this class, then those are the sort of things that we'd be talking about in that class, like how does machine translation work? Even for like, how can somebody who doesn't even know, I don't speak things like ancient Greek, but I can still write programs that can translate for me. How does that work? That would be things we cover in the data mining class. But that's why there's no lab sessions, because I'll be traveling. You will still have a lab this week though, and because of the fall break, I don't want it to be due on Sunday. It'll be due sort of the nominal deadline Tuesday at midnight. But if you collaborate in any way with other people, then you have the extension until Thursday. So hopefully for this class, there will not be too much things that you have to worry about over fall break. Any questions on that at all? Okay. This week's quiz, so we'll still have a quiz on Wednesday, but it'll be entirely a review quiz. There's no new handout to practice. And what you should expect, though, is questions that are a little bit harder than the previous quizzes on the same material. And so if you're going to be practicing, the thing to practice is like the focus on the latter half, like the last problems in all the quiz packets, or all the quiz practice problems, because those ones are harder than the earlier ones. And so I'll be selecting things from there, and also selecting questions that I've just noticed that people have concepts that people are struggling with. So Wednesday, quiz like normal, but it'll be a review quiz. Any questions about that? Okay, last announcement thing, there is another project posted. So your previous project sort of, again, nominally due last night, but you have until tomorrow at midnight if you're collaborating. The next project has been posted, and we won't talk about that today, other than I'll just highlight the due date is you'll have 2 more weeks to go over that, or to finish that. Today and Wednesday we'll finish all the material that you need for that, so you'll be able to get started on that pretty early here. Any questions about anything administrative in this class at all? Okay, then into the technical material. We'll have sort of 2 things to talk about today or this week. The first one is I want to say a little bit more about files and paths, and in particular going back to the question about how exactly does Python know where to look for all of the files it's locating. We'll spend a little bit of time at the beginning of class talking about that in great detail. And then we'll be talking about various data analysis things after that. Okay, so more information about files. I got a big set of notes here inside the README for us to take a look at, and then we'll go over to VS Code and see how this all translates. So the first thing here is that paths are how we specify the location of files. So a path is like the folder that the file is in and the name of the file itself, not just the file name. And again, all of these definitions, all of these terms, never something that I'm going to ask you to define, just things that you have to be able to use or understand in context exactly what I'm referring to. And so there are 2 types of paths, relative and absolute paths. And if you need to use a path in any context in Python or any other programming language, HTML, CSS, anywhere in your computer, you're always allowed to use either a relative or an absolute path. Absolute paths are a little bit different on Windows machines and non-Windows machines. So we'll talk about Windows machines first. Absolute paths always start with a drive letter like C:\/ or D:\/ or E:\. And so this is an example of an absolute path. It tells us exactly where on your computer a particular file is located. So in this case, the file's name is video.mp4. This thing over here is the particular folder that it's located in, and it's located on the C drive. Older Windows machines use backslashes. There's the backslash right here to separate directories. But newer Windows machines use the /, and Windows is pretty flexible. Modern machines that usually doesn't matter whether you use a backslash or a /. Non-Windows machines, absolute paths always start with a /. There is no like drive letter like this. And so this is an example of an absolute path. This over here would be the folder that this file right here is located in. And on non-Windows machines, you always use /s to separate these directories. Everything between a slash here, these are all directories or folders. This up here, that's one of the folders. This folder is inside of this folder. Sometimes we'll use that parent-child terminology again that we talked about with HTML, like this Zoom folder is a child of this programming files folder. And then this video.mp4 would be a grandchild of this folder, and so on. So these are absolute paths. Again, absolute because they tell you exactly where on the computer that your file is located. They always somehow start at like a drive letter on Windows or the /, which represents the like home of your computer on any non-Windows machine. And then a relative path is any path that does not match the rules above. So anything that doesn't have these patterns, doesn't start with a C:/ on Windows or a / on non-Windows, that makes it a relative path. And relative paths, not different between Windows and non-Windows. They're exactly the same on all computers, except that Windows machines, you can use backslashes instead of the / if you'd like. But in general, everybody always uses /s nowadays. So it's to make it universal everywhere. And so these are examples of relative paths right here, because these do not start with something special. They don't start with the C:/ and they don't start with the /. So these are relative paths. And relative paths can look kind of weird. Sometimes absolute paths can look kind of weird, but you always know it's relative because of how it starts. That's what you have to do. You look at how it starts, and that tells you if it's a relative path or an absolute path. Whenever you have a relative path, you always convert it into an absolute path by appending what's called the working directory to the beginning of your path. So as an example, if this is my working directory right here, and my relative path is video.mp4, then my absolute path is you take this and you append this to the end, giving you this right here is the absolute path. We're gonna jump over to VS Code here, and we'll see some examples of all of this accessing the different files, and that will hopefully make things, some of this abstract discussion a little bit more concrete. So back over to VS Code over here. And the first thing that I'm going to do is up here, I have my notes_json.py file already open. And if I press the triangle button over here, then we're going to take a look at what exactly is it that VS Code is copying and pasting down here. Well, it always copy and pastes two things. The first thing is an absolute path to my Python 3 program. And on a Mac or any non-Windows machine, my machine is a Linux machine, a Unix machine, so it's neither Mac nor Windows. But on any non-Windows machine, this thing over here is always going to start with a /, and that'll make it an absolute path. On your Windows machine, this thing over here probably starts with C:/, and then is quite a bit longer than this. This thing over here is also an absolute path, but this is an absolute path to the particular file that I had opened when I pressed the triangle button. If I want to just run this file, this notes_json.py, one of the things that I could do, or I could try doing, is, so let's first copy and paste my Python 3 command, and I'm just going to hit enter right here so we know that that works. It's opening up Python in the interactive Python mode, so that that command works by itself. And now I'm going to try to type in a relative path over here to the right that is going to be equal to this absolute path and open up my notes underscore JSON.py for me. And so the first thing I'll try, notes underscore JSON.py like this, and I hit enter, and I get this error message saying that it can't open this relative path. There is no such file or directory. The reason it can't open this is because every time I give Python or I give the terminal or I give any program a relative path, and again, I know this is a relative path because it does not start with a slash or it does not start with a :/. So I know this is a relative path, and I know this thing up here is an absolute path. Anytime I give any program a relative path, it always converts that relative path into an absolute path. The way it does that is it appends the working directory to the beginning of the relative path. In the terminal, and this will work on any non-Windows computer and like 99% of Windows computers, if you type pwd right here and hit enter, pwd stands for print the working directory. This is the current path that I am going to be looking in for any of these files that I specify like this. And here, this file right here, notes underscore JSON.py, is not contained in my CS40 folder. And so that's why when I run this, it's going to, this command right here, notes JSON.py, that's exactly the same as if I had put this in front of it like that, because it always takes the working directory that you're currently in and puts that at the beginning of the relative path. If I hit enter, this file does not exist because my notes JSON.py is not at this particular location. There's many ways that I can figure out what is the exact location of this file, but VS Code has this built-in one for us for the Python files that we're running with this triangle button. I press that up here, and this is the absolute path, the absolute location that it's contained in, and it contains this particular folder right here. That's the folder that notes JSON.py is contained in, not this folder right here. And so if I'm looking on the left-hand side over here, I can see that I have my topic 6 folder open right here. And that's where I can find the notes JSON.py right there. So one way that I could also run this notes JSON.py file is that I could type in topic 6. I could give it a different relative path like this. I could give it this relative path like that. And I hit enter, and it runs that file now without error. This file happens to not print anything, so there's no output here, but we're not getting this error message anymore that we were getting before, so we know it worked correctly. Again, the way that this relative path is converted to an absolute path is you do the print working directory like this, gives you the working directory that you're in, the thing that gets appended to the beginning of the relative path over here. And now if I put this at the beginning of this, then that would be exactly what my triangle button gives me for that particular file. Pause here, question?
Yeah, so running it in VS Code, that gives you the absolute path?
Pressing the triangle button in VS Code always pastes the absolute path of your Python file right over here. Yeah. Good question. Any other questions so far? Yes.
This one, so hypothetically, sometimes you have multiple like Python files opened up within VS Code, and what if they're in different directories or different paths?
So yeah, you can have multiple Python files open that happen to be in different folders. So let's go ahead and do that. So let's open up, where's a Python? So here's a lab.py from the topic 5 folder right here. And we've had a lot of different lab.py files. So in order for Python to know which one to open up, it makes sense that you have to specify exactly which folder it must be in, because otherwise there'd be maybe 5 different files that it could be running. And so if we look at it, I just press the triangle button right here. It pastes this topic 5 right there. But if I switch over to the notes JSON, run the triangle button, it's going to paste the topic 6 right there. When, let's see. So it's very convenient sometimes to not have to press this, this triangle button and to just be able to type in the name of my file down here. And in order to do that, most conveniently, I might need to change my working directory. So my current working directory is this right here inside CS40. But if I want to just be able to type something like Python 3 and then the notes underscore JSON.py, I can't do that right now because it doesn't, there's no notes JSON.py in this particular folder. I can use the CD command, CD standing for change directory, to change into the topic 6 folder like this. And now if I go up there and rerun this command now, it's going to work correctly because now my working directory is this thing over here, that big long thing that it'll paste in front of notes.json.py when it runs it.
Do we need this the slash after topic 6 in that Python?
Question is, when you do this CD, what is the meaning of this ending trailing slash? And the answer is that there are some computers where this trailing slash has a significance, but it has no meaning on either Macs or Windows machines. So on every computer currently in this room, this slash over here has no meaning. Good question. Another special folder that you'll sometimes see. So maybe some of you have just somehow encountered these things up to this point. But now it's a good spot to pay attention because this next stuff is things that you probably haven't seen yet, that probably none of you have seen yet. And there's this special folder called the ... folder. ... has special meaning. And ... always refers to, so if I type pwd again, here's my present working directory, my current working directory. ... always removes the last folder from the end of this working directory and refers to this thing over here. Turns out that it's a very common thing to want to do, to refer to the parent of the folder that you are currently in. Again, this over here is the parent of this child folder right here. And if I do cd space ... that space is required. Cd space ... that takes me back to my parent, or up one level in the folder hierarchy, giving me back to my CS40 folder. Another thing that's very useful inside of the terminal is that it does what's called tab completion. Interactive Python also will do this for you. But whenever you're typing something, if you press tab, it will complete up as far as it can until things are no longer unique. So like, I'm not really that fast of a typer. I can't type the OPIC_0 really fast, but I can press tab really fast and it types all that other stuff for me. Then I press 6 and I press tab and it types all that other stuff for me. So I don't have to worry about making typos. I don't have to worry about carpal tunnel. I just press tab and it does that for me. This last command right here that I typed in, ls, stands for list all the files in the current folder. So ls lists all of these files right here. And that's another useful thing as you're navigating your folders, your files on your computer, just to figure out where you are and what you're working with. I'm going to come back over to GitHub for a second. All the things that I just talked about are in the notes right here, this pwd print working directory. This works on 99% of Windows computers and all non-Windows computers. Some Windows computers, you'll have to do cd just by itself to print your working directory. cd followed by a path will, on every computer, will change your current working directory. And then ls will, again, on every non-Windows machine and 99% of Windows machines, will list the contents of that folder. Other Windows machines, you might have to type dir. So there's a little cheat sheet of those things. For this class, you don't need to be experts in any of that. I will start using that a little bit in the terminal down here, but as long as you're able to sort of figure out how to access your particular files from within Python, then you'll be good for this class. Follow-on classes will be going into a lot more detail of this terminal, though, in those commands. It's a good time to pause and see if anybody has questions about any of that. Yes.
In one of the labs before, when I was trying to download it,
Hmm?
it had a parentheses at the start of the entire line, and then I thought that was also considered setting the word.
So you're saying when you did something like pip install YouTube download. So this is all just like output of this particular command right here. And yeah, it's not going to change your working directory at all. One of the reasons, so again, on everybody's machine, this prompt down here can look a little bit different. One of the reasons that I have my prompt set the way I do is so that I can always see what my working directory is over here. I can see where the files are located. But yeah, the terminal is a very customizable thing, and so it's going to be different on everybody's machine. But if you do run into questions about things, I can always take a look at it and then help you figure out what's going on. Okay. We're gonna come back to this, these file paths here in a little bit. When, again, at the beginning of class, I asked everybody to make sure that you have these two files downloaded, this JSON.py and the zip files up here. We'll be accessing the contents of these zip files from within Python in a little bit. And in order to do that, we're going to need to make sure that our paths are all working correctly. So we'll be using the paths again here in a little bit from within Python when we access the contents of these files. But we're going to start looking at this Python file without any file path information and just talk about what this idea of JSON is. So again, up here, I have the notes_JSON.py. This JSON is pronounced JSON, like the person's name, pretty much. And what JSON is so here inside of this quotation mark, this tweets_string, I have a string that contains what really looks like Python code. And this is a very common format for delivering data from one place to another. And in particular, Twitter stores all the tweets that have ever been sent inside of files that use this JSON format. That are stored basically just as Python lists, where the list items are dictionaries and where the dictionary contents is information about the tweets. I'm going to delete these quotation marks just for a second, like this. Actually, sorry, before I do that, I want to load this up in Python, and we'll just verify that this is, in fact, good Python code. In order to do that, so my working directory right now is my topic 6 folder, so I can type python3-i -o, press the tab button, get the underscore, and now press the J button, press the tab button, and it completes that whole thing for me. So python3-i notes.json.py is one of the common times when I don't use the triangle button, but I type things out, is when I'm using Python interactive mode, because it's just easier for me to type this than it is to go figure out where I'm supposed to add that -i in that big long command. But I hit enter. I know I'm in Python interactive mode now because there's these 3 greater than signs down here. And I know I've loaded up this file because if I type in tweet string and I type in TW, well, I don't want to type that whole thing. I press tab like that, and it gives me the contents of this string up here. We see these \ins inside of this string. We know it's a string because it ends in the quotation mark. We see these \ins inside of here because those correspond to the new line characters inside the tweet string up here. And anytime you just display the tweets string, anytime you just display a string by itself, the \ins don't get converted into their special formatting. If you wanted it converted, then you would print it out like that, print it, and now it gets displayed in the same formatting that we had up above where the \ins, all these special formatting characters actually get converted. And in particular, notice that if I do something like tweets string @0 square bracket 0 like this, and I hit enter, this tweet string is in fact being treated as a string. And so this is the 0 character, the 0 index of this tweets string right here. Do change that to a 1, we get the \in that corresponds to that new line right there. And if I did, I can do slices like 1 to 10 to get various substrings out of here. But this is just a string. The contents here look like Python, but it's just a string treated just like any other string. In order to actually get the contents of here, like use them in Python, one of the things that I can do is I can delete these quotation marks like this, save that, come down to my terminal, I'll press Control-D or type exit to leave interactive Python, press the up arrow to get back to my previous command. Notice that I'm running the notes_json.py again in interactive mode. I press enter, and now my tweets_string is no longer a string. Type tweets_str like that, it is no longer a string, it's a list. If I type tweets_str like this, notice you don't see any \ins in here. Notice there's no quotation mark at the end of here. It ends in the square bracket, so I know it's a list. And when I do the tweets_str at position 0, that gives me the first entry of this list, which is this big dictionary right here. And if I wanted to say get this index into this dictionary, then I can do tweets_str at position 0, getting me this dictionary, at source like that, getting me this Twitter web client. Or maybe a more useful, interesting thing is at text like this, getting me this particular text of this particular tweet that Donald Trump sent. It's a good spot to pause and see if there's any questions about, I just did a lot of weird things. If there's any questions about any of that, feel free to ask. Is this all mostly making sense so far to people? Handful of head nods. Okay. So one thing that I could do if I was Twitter and I wanted to distribute these tweets very widely to people so that people can analyze them somehow, I could distribute just giant Python files that contain the tweet information. But it's a little bit dangerous to run Python files because a Python file can do anything. It can delete the contents of your computer. It can turn your computer into a, like, I don't know, mine Bitcoin for somebody. It can also, it's a very dangerous thing to run random Python files from the internet because they can do anything. And so it's customary instead to distribute these JSON files, which are just the strings that contain this special subset of Python of lists and dictionaries, and it can't do anything else. It can't print stuff. It can only contain this information. In order to actually use the information inside of that's formatted this way, Python has a built-in module called JSON. You do import JSON like this, and that will get you access to it. And then there's a function json.load s. Here, this S is not standing for plural, like load multiple things. This S stands for string, load from a string. And so this one up here is called tweets_string. This one down here I'll call just tweets equals json.loads of tweets_str, like that. And save that up here, down here. Up arrow, rerun this, loading interactive mode, no error messages. If I type the tweets_str like this, I still get it in string form. But now if I type the tweets by itself, now I get it in list form where I can access it like normal Python lists and dictionaries. So this is the big high level main thing to make sure that you understand is that if you have a string that contains this JSON code, this Python code that looks like Python with lists and dictionaries, then the way you access it from within Python is you import JSON and then this JSON.loads function. Question is, why would we do that? And the answer is that, so in this case, we're looking at tweets sent by President Trump in your lab this week. And so here is one example of a JSON file that contains a whole bunch of tweets sent by President Trump. And here I've just clicked on this 2009.json file, and you can see that the contents of this looks like that Python code. It has a list and a dictionary right here with stuff inside of it. And there's a lot of these tweets inside of here. We scroll like way down, just tons and tons of tweets inside of here. If I want to be able to use this in Python, I can't just run this JSON file. Notice there's not even a triangle button up here in VS Code for me to execute. If I want to have access to this information, then I have to first load it. So we'll do we've seen how to open files before with open. The file that I'm accessing is going to be inside of this data folder. So I'll have to say data slash and then condensed underscore 2009.json. And the encoding, you always have to know the encoding every time you open a file. JSON files are always encoded in ASCII. Encoding equals ASCII. And then as f.read. This is my text of the file. So I'm loading up this file right here, getting it as text. We need an equal sign there, putting it into this text variable. And then now that I have a string that contains all this JSON, like up here, I have a string that contains this JSON. It doesn't matter where I get that string from. Up above, I typed it in manually. Down below, we're loading it automatically from this file. I can convert it into the Python string and dictionary type using, we'll say data equals JSON.loads text like this. And we'll save that up here. Down here, Control D, exiting out of interactive Python, up arrow, Python 3-i notes underscore JSON.py, reload that file. Down here, type data, and we get this big long thing that contains all of this information that was stored in this file that Twitter was distributing so that people could analyze President Trump's tweets. And if I want to know now how many tweets, for example, President Trump sent in 2009, I can use my length function, length of data, like that, and we get there were 56 tweets contained in this JSON file. I know that it's corresponding to this JSON file right here because this data file, data corresponds to JSON.loads of text, text corresponds to f.read, and this f corresponds to this file right here, data slash condensed underscore 2009.json. And so inside of this file right here, there were 56 tweets of information. So it's a long-winded way of saying the original question is like, what's the purpose of doing all this? Why do we care? The reason is because people distribute these JSON files that contain these lists of dictionaries or somehow this structure of Python code, and we want to be able to access it within Python in order to do our data analysis. And in order to do that, you'll always follow a pattern that looks something like this, where you're opening up the file and then reading the file and then converting it using this JSON.loads into actual Python data that you can manipulate directly. Did that answer your question somewhere in there? Yes.
So the difference between the with open and with import JSON. So do you need both of those to make it work, or are those doing different?
Good question. And the question is, what exactly is the difference between the import and this like with open thing? They're both somehow opening stuff. The open function specifically opens up a file that is not going to be treated as Python code. It can open up any possible file type. In this case, it happens to be JSON data contained in the file. But the open function can work with any possible file type. And it does not run the contents of that file in any way. It just gives you access to read the contents of that file, and then you're allowed to do whatever you want with it. In this case, we're converting it to JSON so that we can analyze it, but we could be doing anything else with it. We can do whatever we want to do to manipulate this file. The import is for libraries that are either built into Python or things that you have pip installed. The JSON, whatever comes to the right of import is sometimes called a module. So JSON, if I hover over it like this, it tells me module JSON, and it tells me all the information about from the documentation about things that you can do with JSON. I look down here. This looks sort of like the format of things that we were seeing above. Yeah, so this is for actually like loading Python code. Anytime you do an import of something, that gives you access to more functions. So here, JSON.loads, whatever comes to the left of the dot, was imported somewhere else. So this JSON had to be imported up here. If I don't have that import like that, come down here, Control D, exit interactive Python, up arrow, rerun that command. We get this name error right here. This name error happens on line 19. Line 19 up here is this one right here. VS Code is helpfully giving us the squeal right here, saying that this JSON, it doesn't know where to look for this loads function because JSON, it doesn't know what that is. In order to have access to it, we need to import it. Come down here. Let's see what happens if we make a mistake in what we're opening down here. Let's say I forget that data slash like that. Save that. Come down here. Up arrow. Rerun that. We get this file not found error. The error message for the open function will be file not found if the thing over here, if it can't figure out what that path is supposed to be. And again, it always takes this and appends it to your current working directory in order to figure out where that particular file is located. So here, because I put that file inside of this data folder, and my current working directory is the topic 6 MATLAB, type pwd, topic 6 Python MATLAB like this. In order to get into data into condensed 2009.json, I have to add that data slash right there. That answer your question somewhere in all that?
Yes. I'm just wondering about the tweets line now. So that's
this
like
one?
loading all of the JSON files.
So what this line is doing right here, anytime you see JSON.loads, this has nothing to do with like opening a file. JSON.loads has nothing to do with opening a file. Instead, it takes as input a string and it does something with that string. It loads that string. So here in the first example, this tweets_string, this JSON information was hard coded into this file somehow. I typed it in manually. And so you can access these two tweets this way. Basically, there's like no actual practical situation where you would want to do this though. You almost always store your information in a file somehow that's separate from your Python file. And in that case, the pattern is that you'll always open it, read it, and then JSON.loads to get access to the actual like semantic content rather than the text content. That answer?
Yeah.
I remember we talked about something similar earlier where Python had, you were able to do one line of code versus like 2 or 3. Is this the quicker version or is there one way to make it all one line where it also reads it and opens it?
The question is that, so previously we talked about that when you do this open function, open is like the most powerful way, the most general way of using this open function is that you can load things. So R stands for read, then B stands for binary or bytes if we read it in binary form. And let's go ahead and I'll save that for a second, come down here and run that. And you'll see that we get this error message. This error message happens on, so whenever you encounter an error message, you start from the bottom and read up to the top. It says a type error right here. JSON object must be string, not bytes. That's maybe not super useful for me, so I'm going to keep going up. Here, I see that this is the very bottom line, this line 312. My file doesn't actually have 312 lines in it, and I can see that this error message is not happening inside of my file. This is happening somehow built into Python. So I keep going up until I encounter my file, notes_json.py right here, line 23. Go to line 23, and this json.loads we say it's throwing this error. The reason we're getting this error is that this text object right here needs to be a string type and not a bytes type. But open with this B gives us a bytes out and not a string out. In order to convert from a bytes to a string, we always do the decoding. And so text equals text.decode. And then we decode it as ASCII like that. Come down here, Control D. So, there we go. Up arrow, rerun this. And now there were no error messages because now this decoding line converts things from the bytes to the text. And so the question was like, okay, if this pattern is so common that after you read a bytes, you convert it to text, is it also common enough that to go straight from the bytes to the JSON to combine these two so that you can do all of this stuff here in just one line? And the answer is yes, there is a built-in JSON function that loads from a file instead of from a string. I never remember what it is though, so I always use this loads function. But if you wanted to look up in the JSON documentation or just Google online, like how to load directly from a file in JSON, you can, and you can replace these 4 lines with just a single line if you do that.
Is there a reason you decode it with ASCII instead of like UTF-8?
Question is there a reason that I decode it with ASCII instead of UTF-8 or something else? And the answer is that I could use UTF-8 if I did that, save that, come down here, Control D, up arrow, rerun it, and we do not get an error message. If I did something else like say UTF-16, come down here, Control D, up arrow, rerun it, I'm going to get an error message about turns out not to be a valid encoding for that particular text. And it turns out actually that JSON, the JSON format is required to be ASCII encoded. And so when you're decoding it, then ASCII is always the right choice to use. UTF-8 happens to be backwards compatible with ASCII, so sometimes people will use UTF-8 and things will still work. But ASCII is sort of like the most technically correct thing. That answer your question?
Yeah.
Great questions. Any other questions so far? Okay. So what if I want to so yeah, we're going to do some data analysis here on these tweets. And so we can use whatever basic Python functions that we've seen or that we want to use in order to do this data analysis. We've seen this length function before. If I do length of data like this, it tells me the total number of tweets there are, because length tells us the length of a list and data is stored as a list. It's a list containing all the tweets. What if I want to say, not just count all the tweets, but count only tweets containing a certain keyword? Then one thing I can do, I'll go ahead and do that as an example right here, that will loop through all of the tweets using an accumulator sort of pattern. So for tweets in tweets And I'm going to change this from data down here to be my semantic tweets up here. And then I'll go ahead. I don't need to comment this line out because this tweets variable will be overwritten by this tweets variable. But just to make it like absolutely clear that we're not looking at this data up here, but that we're looking inside this file right here, I'll comment that out so that this tweets is this here. And again, anytime I use a for loop, I always like the singular plural pattern. So it's very easy for me to see at a glance if I'm talking about the list or if I'm talking about the item inside the list, the value of the list. So for tweet and tweets, and let's have an if statement. Let's try if Trump in tweets, then num Trumps plus equals 1. So I want to count how many tweets contain the word Trump that were sent by Trump. So num tweets equals 0, started at 0. Now loop over the tweets and somehow check each time to see if the word Trump is in that tweet. And then at the end, we'll print that out. Num tweets equals, comma, num tweets, like that. Save that. Yes, question?
Would it be num tweets or num Trumps for the variable?
Thank you. So I mixed up my variable names here. Up here I have num tweets, down here I have num Trumps. Let's just go ahead and see what's going to happen when I run this. And we get no error messages at all. When you, in Python, when you have a mistake like this, that you have a typo, it's very common that you don't actually get like an error message explaining that you have a typo. You just don't get a good answer. Like we have num tweets down here equals 0. But if I come over here inside of here and let's just look for the word Trump, not Tump, Trump. Then there's a lot of tweets that somehow contain the word Trump inside of them. And so it's definitely not the case that the answer should be 0. And so let's go ahead and change this back to num, or not back to, but to num tweets like this. And we'll see if that fixes my problem. Down here, Control D, getting out of interactive Python mode, up arrow, back into interactive Python mode in that file. And we still see that num tweets equals 0 right here. And so that nothing is actually being printed out. So what we're going to work on here is we're going to see like my thought process of debugging this, my thought process of going through this and figuring out why my code is not doing what I hope it might be doing. And in the process of doing that, we'll learn a little bit more about working with these JSON files. So if my hypothesis now is that if this is always coming out as 0, then maybe this line right here is not actually being executed for some reason. I can just double check to see whether this line is being executed by adding like a print statement right here. Will this run? Question marks. Save that. And come down here, Control D, up arrow. I'm actually going to get rid of the interactive Python now, just so that it goes straight back to the terminal. And here I can see that this print statement, will this run, is like not running at all. That's weird. I thought it would come inside of here. Let's come up here and let's just make sure that we're going inside this for loop at all. Inside for loop like this, save that, come down here, up arrow, rerun this, and we can see that it's printing out inside for loop a whole bunch, but it's not printing out will this run at all. So somehow this if statement must be coming, is this if statement being evaluated as true or is it being evaluated as false? It's being evaluated as false. This is never happening. So I have to think about, okay, why is this being evaluated as false? One thing that I can do to figure that out is I can actually print out this value of tweet right here. I can do print tweet equals, comma, tweet, like that. And then I'll be able to look like at actual each iteration of the for loop. Let's look at what the result is. Is this going to be like true or is it going to be false? So we'll save that, come down here, up arrow, rerun it. And here we can see that it's, so there's a lot of output now. a lot of output now. It's printing out inside the for loop a lot like it was before. And then in between each of those, it's printing out this tweet equals so that we can see like what is the contents of each of these tweets. And if we look at this very last one down here, I can see that there is in fact this word Trump somewhere inside of this tweet, in this very last one. But even on this very last tweet right here, it's never actually printing out, it's never going inside of this if statement right here and printing out, will this run? I'm just going to reiterate this conundrum right now. I see this word Trump inside this tweet. This word Trump is inside this tweet. This tweet corresponds to this tweet right here. But somehow when I do this if statement right here, it's not being evaluated as true. Does anybody have a guess? Want to venture a change that I might make to this to try to get this to evaluate as true for this tweet? Joe?
Well, maybe it's, but maybe that whole thing is not a straight stuff.
So this is definitely on the right track. This whole thing over here, it turns out is in fact not a string. It is a dictionary. We know it's a dictionary because it has these curly braces around it. And when I'm checking is Trump in a dictionary, it doesn't like go inside the dictionary and look to see is Trump in any of these things. If I want to actually like go inside this dictionary, inside of the text of this tweet, I don't want to say if Trump in tweet, I want to say if Trump in tweet square bracket text like this, because the tweet square bracket text, this right here will give me this string right here. This is my whole value of tweet right here. I know this is my value of tweet because I'm printing out the tweets right here saying print tweet equals tweet. And now I know that tweet at position text will, here's the key, the key text, here's the corresponding value. And this contains the word Trump. And so now our new hypothesis is that this is what I wanted. This will evaluate to true. And let's go ahead and save this, come down here and rerun it and check that, up arrow. And now we can see that will this run is being printed out a whole bunch of times. And in fact, that 47 out of these 50 some odd tweets, President Trump mentioned himself somehow. If I want to remind myself what is the total number of original tweets, I can go down here and type len tweets equals, comma, length of tweets like that. Save that down here, up arrow. Yeah, so 47 out of the 56 tweets somehow mention the word Trump inside of the text. Any questions about why we needed this square bracket text right here in order to access the actual text of the tweets? Okay. Let's see, in order to make sure that I'm really doing this analysis like super correctly though, let's not just here, like maybe I'm missing some tweets somehow. So down here, I want to add an else statement, and I'm going to put this print statement down here inside the else like that. So every time I don't find the word Trump inside of a tweet, I want to print out what that tweet will be. And then I'll go ahead and remove all of these other print statements that I'm not actually using anymore. So we'll save that. The goal now is I'm printing out the contents of the tweets that do not contain this word Trump. I'm printing out the contents of the tweets where this evaluates to false. And I want to make sure that when I look at that just visually, I'm not going to see the word Trump anywhere. Say that, come down here, up arrow, rerun, and we get a handful of tweets printed out up here. And this one, okay, if we look at the text in particular, it doesn't contain the word Trump anywhere. I don't really want to look at all this other junk down here, so I'm going to change this to tweet at position text, like so. Tweet at text. I didn't have to change this stuff inside the string over here, but when I'm printing out so much information down here, it's just really good habit to make sure that whatever you have in your print statement, whenever you're printing a variable, you should tell yourself what that variable is that you're printing, make it much easier to follow along down here. And let's make this a little bit bigger. And somewhere, looks like they're right here. This one contains the word Trump inside of it, but I'm not actually identifying this particular tweet. So this particular tweet right here contains the word Trump inside of it. I know it contains Trump because I'm visually looking at it. I see that it contains Trump right here. But if I look at my code up here in this print statement right here, this print statement is inside the else. So this up here must have returned false and did not actually did not actually identify that this URL contained the word Trump inside of here. Why did this evaluate to false on this particular string? That's it.
Non-capitalized.
Yeah, everything in Python, again, is case sensitive. And here we have uppercase Trump, here we have lowercase Trump. One of the common mistakes that students make is when you have this in keyword, you think that it's looking for the word Trump, and this is not the word Trump. It's like combined somewhere else and a whole bunch of other stuff inside of a URL right here. But that doesn't matter. As long as this string is contained somewhere inside of this string over here, then this will evaluate to true. The reason this evaluates to false is because this is lowercase t down here, and this is uppercase t up here. So in order to make this work a little bit more like Trump can mention himself in any capacity, I can say uppercase Trump in tweets or lowercase Trump in tweet, like that. Save that, come down here, rerun it. So previously we were getting 47 out of 56 tweets mentioned the word Trump, rerun it, and now we're up to 50 out of the 56 tweets actually mention the word Trump. And again, because I wanted to match either lowercase or uppercase Trumps, because he might talk about himself in either fashion. If I really wanted to match like all possible cases of the word Trump, well, there's a lot of them. Like maybe he might say like Trump all uppercase shouting his name, tweet in text like that, or we want to be able to match things like that as well. And as soon as you start getting into like these weird capitalizations, there's just a lot of possible different combinations. We don't want to have to list them all out. So the sort of like right way to go about this, anytime you're searching a tweet to see whether it mentions a string or not, if you do if lowercase Trump in tweet at text dot lower like this, the lower function converts everything over here into lowercase, and then we look inside of the lowercase string for the word Trump. If whatever is inside of this is all going to be lowercase, contains the word Trump, then it doesn't matter whether it was originally capitalized like this, or like this, or like this, or anything else. This down here will evaluate to true. Save that, come down here, up arrow, rerun it, and we get that there are still 50 out of 56 tweets mentioning Trump in any of these forms. Again, very, very common pattern to any sort of data analysis, but definitely something that you'll have to use in this upcoming lab and future projects, is that if you're searching to see whether a tweet contains a particular word, make your search happen in lowercase and convert the tweet to lowercase, do the search in the lowercase. Any questions about that?
How do you open that zip file within VS?
Question is over here, all of these files are JSON files. What happened to this .zip at the end? VS Code didn't open the zip files. I unzipped the file using whatever zip program I have on my computer. However, I would normally unzip a program on my computer and do that until you get access to the just JSON file by itself, and put those JSON files in this data folder by itself, and then you'll have access to them.
So say you're trying to have the name Trump and Chicago in the same one, would it just be hands, or would that not be?
Yeah, so now the question is, what if we wanted like maybe tweets not just talking about the word Trump, but Trump and something else. There's a number of ways that we could do that, but a simple one would be if Trump in tweet and so the question was specifically about Chicago. Chicago in tweet text lower like that. And now this will find the number of tweets that mention both the word Trump and the word Chicago in the same tweet. Up arrow, run it. And now there's only one tweet from this from 2009 that mentions both the word Trump and the word Chicago. A very common mistake when you're looking for multiple things. So this is a good spot to like wake up and make sure you pay attention to, because this is like, I don't know, this mistake happens all the time, is that people often say if Trump and Chicago in tweet text dot lower. Try to do this. Let's save this, come down here, up arrow, rerun it. And this one happened to give us the same answer. I'm going to change this so that it gives us a different answer here. Chicago and Trump, like this, up arrow, rerun it. Now we get back to the 50 out of 56. Most people, when you think about this, you think that somehow it's doing something like this, like if Trump and the word Chicago and the word Trump are both in this, then be true. This is not how Python interprets it, though. Python interprets this statement as if Chicago and all of this stuff. Chicago is interpreted about like whether it's truthy or falsy. Chicago is not an empty string, so it is truthy. And then it just checks if Trump is in all of this. And so this here is only checking to see if Trump is in the string, totally ignoring the word Chicago. So this is incorrect. The thing to the left of the and will not get applied on the in over here. And this one up here is the correct way to do it. You really do have to repeat those tweet text.lower things each time. Save that down here, up arrow, rerun. And now we're back to one tweet.
And couldn't you do the thing where you do put the parentheses around it? So if Trump and if parentheses Trump and Chicago and Letterman and Long are in.
So the question is, what if I do if Chicago and Trump in tweet text dot lower, will this work? And let's find out. We're computer scientists. Scientists run experiments. So we're running an experiment. Up arrow, rerun it down here. And we get 50 out of 56 are found. Let's take a look. We haven't talked about what happens when we do this right here, but let's open up interactive Python. It's a great environment for running experiments. And let's see, what is Chicago? Chicago and Trump. What is that? Chicago and Trump happens to be equal to Trump in Python. Whenever you have the and keyword and it has two truthy things on both sides, it always takes the rightmost side, and that is the return value of and. So the and always accepts like truthiness and falsiness and always returns truthiness and falsiness. And it can't be combined in Python with the in keyword in any way. If we had Chicago or Trump, then it takes the thing on the left-hand side instead of the thing on the right-hand side. Yeah, so the in keyword is nice in that it can make our code a little bit, I don't know, kind of readable. Like reading this is not too hard, but the in keyword is really easy to make mistakes with if you have something like this or something like this. Yeah.
You want to find the first time here, let's say you're kind of trackable, so let's focus on the first time. What would you do?
So now the question is like here, in this sort of accumulator pattern, what I'm doing is I'm counting each time some particular event happens. What if I wanted to do something else? Well, there's a number of different other things that I might want to do. One is I might want to just like filter all the tweets that match this pattern. So like output tweets equals the empty list. And then down here, instead of adding one, I'll do output tweets dot append of tweet like this. Again, the accumulator pattern, you're always somehow starting with like whatever the most empty thing is for your type, and then somehow adding something to it each time an if statement is true. And so previously we were just counting, so adding one. Now we're storing all the tweets like that. And now down here we have like my output tweets contains all of the tweets that match this particular condition up here. And now if I wanted to do some further processing of those output tweets, I could, for example, get what is the very first output tweet that satisfies this condition. And I'll call that first output tweets equals output tweets at position 0 like this. And now the first output tweet, print first output tweets equals first output tweets like that. And it'll actually print out for me which one is the first tweet that that Trump sent that mentioned both Chicago. Here's Chicago and the word Trump like that. All great questions. One more thing I want us to talk about is that in lots of situations, you're not going to have just a single file that you want to analyze, but you're going to have many JSON files. And in particular, with Trump here, we have something like 10 different JSON files from 10 different years that contain different tweets in it. And it would be really nice if I could, like, I don't know, count how many tweets Trump has sent overall, or count how many tweets Trump has sent matching some certain conditions like this, without having to like manually, individually copy and paste this 10 different times. Anytime we have something that we want to repeat multiple times, like the go-to thing that you should be thinking about is a for loop. And what I'm going to do is I'm going to do a for loop over all of these JSON files and put them all together into sort of like one condensed data set. In order to do this most cleanly, I'm going to just comment this out above here so that we don't destroy that. This file is going to be uploaded to GitHub after class, so you'll be able to come back and look at this if you want. And so I'll leave that commented out, so again, we don't destroy it. But I'm going to create another data set loading thing down here. We're going to have anytime we have a for loop, in this case, we're going to for loop over files. We need to have some sort of thing that we're looping over. Very common to loop over a list. So I'll create a variable called paths. Again, all my lists end in S's, and let's do data / condensed _ 2009.json, data / condensed _ 2010.json, data / condensed _ 2011.json. And we'll start with just working with just these three files right here. And now I have my list. I can do something like for path in paths like this. And this code up here was opening up a particular path with open path encoding. I'll go back to the original one that I did, ASCII as F, and then text equals F dot read, and tweets equals JSON dot loads of text like this. And this is going to create this tweets variable that I'll have access to down below. What I have written so far, though, is a mistake, because every time I go through this for loop, I'm going to be overwriting this tweets variable with new stuff, forgetting what it used to be, forgetting what it used to contain. So this is another example where I'll want to use that something sort of like an accumulator pattern. starting off with the empty list down here for my tweets. And then down here, instead of tweets equals this, I'll do a tweets plus equals this. So adding on to the end of this list, all the new tweets that I've gotten down here. We'll save this, come down here, up arrow, rerun it. I just want to see what are the new values for my number of tweets matching this Chicago and Trump condition, and my new value for the length of tweets. So up top, 1, down below, 56. Rerun this. Now there are 5 tweets in 2009, 2010, and 2011 that mention both Chicago and Trump sent by President Trump's account. And the length of tweets is, the total number of tweets sent in those 3 years is 972. This is still not the perfect solution to this problem, because up here I have to write out all of these paths manually, one at a time. Ideally, we would be able to like automate that even further. We will pause here though and do the rest of that automation next class period. This will be the end of today. Reminder, Wednesday quiz on all the review stuff. And but I'm happy to stay again after class as long as people have questions. If you have questions about anything, feel free to come ask them.